Hello guys, today we're gonna talk about AMC 8, number 19 from 2014. So let's read it. A cube with 3-inch edges is to be constructed from 27 smaller cubes with 1-inch edges. So we can draw this with 3-inch length, width and height, cube, and we can create a depth to show the three-dimensional shape. And it says it's constructed from 1-inch smaller cubes. So that means each length here is going to be 1-inch. So you have this smaller cube that make up the large cube, which comprise 27 smaller cubes. Okay, but out of these, there will be 21 red cubes. And again, it's made of 1-inch by 1-inch by 1-inch. And then you want to have a white, which I will draw with black here. 1-inch, 1-inch, and 1-inch. But like I said, you have 21 of these, and then you have, for the white, you have 6 of them. Okay, now what's the next piece of information? If the 3-inch cube is constructed to have the smallest possible, we want the smallest possible wide area. What fraction of the surface area is white? So this is the key information, which is our goal. So we can set it up like this. Surface area of white in the big cube here, as you can see on the upper right corner, and then divided by the total surface area of the big cube. Okay, so to create the smallest, one cube can be placed in the very center of the big cube here, because in the very center, it's not exposed to the outer surface. Therefore, we can put one white cube in the very center. Okay. Now, I can draw the 3 different layers of the outside of the cube. So say we have this as a top, and then here is the middle layer. Well, you can kind of think like a, let's go back to our picture here, like a first floor here, second floor there, and the third floor here. Okay. So for the top view, we'll think it's like a third floor. How about that? If it's a building, third floor. And the middle layer, or middle floor, and here is the bottom. But imagine you're looking at this from the very bottom here. Here's your eyes. Okay. And in the middle, say we can kind of see through. And on top, you can see we are watching from the, let's make it better, from the very top here. Your eyes is there. Okay. So again, I'm gonna label with top, bottom. In the middle, just imagine you're seeing through from the top. Okay, so here we have. So in the very middle, it's gonna expose the least surface area of the white. So I can put 1 here. Okay, this represents the white cube. 1, 2, 3, 4, 5. This way I'm exposing the least area. And unfortunately, I'll have to expose this as white on the side. Okay. Alright. On the top, because we use 5, we have to use either top or bottom for the extra white. And I'm gonna choose top. It doesn't matter whether you choose top or bottom. And you want to place this white cube in the center. That's because if you place it on the side or on the corner, then you get to expose more white area, and that's not the goal of this problem. And therefore, we want to have another area on the top here. Okay. And because we use all 6 white cubes, we don't have to worry about the bottom layer. There's nothing shaded. Okay. So in other words, if you look at the cube here, we're gonna have in the middle layer, we're gonna have a 4 surface area exposed. So if you want me to shade it in this big cube, I'm gonna shade it here. There's 1, 2, and then on the other side you have 2 more, which is not easy to draw here. So you have 4 exposed area, the white area, and then over here you have one on the top. So I will draw another on the top. And you used all 6 white cubes, and if you go back to our original goal here, there are 5 exposed white surface area for each squared, and then the total surface area of a cube will be 6 times, because there are 6 sides, 3 inch by 3 inch, and that makes it 54 on the bottom, and you cannot really simplify here. Therefore, the answer must be A.